We now would like to welcome our next panelist, Dr. Rolf Bruingens, to join our two speakers, Mr. Sofian Farah and Professor Istvan Kirsty, in the panel discussion. Please welcome them.
Good afternoon, colleagues. I hope you can hear me. We are still in session one, which deals with the transition from research to operations in rain enhancement, case studies, and the roadmap. And the specific presentations that we've just heard now from Mr. Sofian Farah and Professor Istvan Kirsty related to the systematic approach to evaluate new seeding nanomaterial. So this is an exciting new development that happened thanks to the IREF program, where we have something new in terms of seeding material for the first time, probably in the past 20, 30 years. It's a difficult path from developing something new in the laboratory and then systematically taking it into the real atmosphere and eventually into operational seeding. And so in the discussions you've heard so far, you heard Mr. Farah explaining the long history in cloud seeding and rainfall enhancement in the UAE. But from Professor Istvan Kirsty, you also heard the important role that modeling plays in this. So it's a combination of all the tools that we have as atmospheric scientists that needs to be on this issue. But not only that, there's engineering, there's IT, there's aircraft instrumentation, there's a whole range of skills. So Dr. Rolf Bruingens, he's a scientist at the National Center for Atmospheric Research in Boulder, Colorado, and he's also the co-principal investigator of the second cycle awardee with Dr. Paul Lawson in the USA, and they have started some unique work in this process to take things from research to operations. And I would just like to ask Dr. Rolf Bruingens to give a brief overview of what they've done up to now and what are the plans going forward. So Rolf, over to you.
Based on the presentations, those are both important and valuable information. During our aircraft campaign in the UAE in 2019, basically what we did is also worked with NCM to test the particle size distribution of the new nanomaterial. During the project there was a lot of work done on developing a method. We tested several methods for the dissemination of these particles, and we ended up with the flares. However, during our limited field program, we were not able to do any in-cloud measurements because the proof on the pudding is basically what happens in the cloud. Our models are limited because they have certain assumptions in terms of particle size distributions, in terms of hygroscopicity. And so these measurements are important to initially start the modeling, but the real test happens in the clouds. We were planning to do these tests in West Texas this past summer. However, during the La Nina, we had one of the driest years in West Texas and no clouds. We are standing by at the moment. We have tested the flares in Texas. They are working well. We have sufficient amount to do the test, and we are planning to do these tests in February, March, or April timeframe, when we have convective clouds after the winter again. This is exciting, but especially the in-cloud measurements are really important, and to take this further in terms of our measurements in the UAE. In the context of the UAE measurements that we took there seems to be a lack of coalescence. Although there is a broad size distributions of particles, it seems like the dust particles in the tail are not always that hygroscopic, and you only get a very few large drops. So in this sense, the new nanomaterials may make a tremendous difference in that. And this is very difficult to sometimes also in the modeling, but what we did find is that coalescence is not very active in the UAE clouds. And so we are testing this in West Texas initially, which is similar to some extent to the Queensland clouds. And then basically, hopefully, further tests in the UAE may provide further results in this regard. But I think it is time to go to the in-cloud measurements and also assessing what is happening in the cloud. The UAE also has a very advanced radar network, dual polarization radars. The combination of aircraft measurements and radar measurements would really help in developing our understanding of the effects of this nanomaterial. Thank you.
Thank you very much, Roelof. So I want to turn to Mr. Sofian Farah. He's a meteorologist and cloud seeding expert at the National Center for Meteorology in the UAE. He's got a long history as a meteorologist in forecasting, but also in the history of the whole program. And so I would like to ask him how excited he feels with his colleagues about this new seeding material, the nanomaterial that was developed by Professor Zhou and her colleagues. And what in your mind have been the most challenging stumbling blocks to move from research to operations?
Thank you very much, Dr. Dion. Actually, my colleagues are happy with these materials at this moment, but unfortunately, it's not been tested yet in the convective clouds, as Dr. Roelof mentioned. The challenging for the dispersion or dissipating this material into the cloud is mostly being done by the factory of rainfall enhancement in the country that belongs to the National Center of Meteorology. I think the most important now is going forward to test this material in the cloud. The other thing that filling this material is taking a little bit of effort, because it mostly is manual, and we are looking or searching to be semi-automatic or automatic, that for a mass production for in the future. We hope that this material will achieve the improvement and satisfy the Committee of Cloud Seeding. And we are looking to make it a revolution and make a revolution in cloud seeding. As I told you that we are overcome the dispersion, this material into the cloud to avoid the blocking or any, that's from my side, yeah. And what was the other question, please?
No, it was about the challenges and the excitement regarding this new material. Now, I can just mention that Dr. Linda Zhou has brought a completely new field of expertise into the field of rainfall enhancement by bringing her skills and those of colleagues that are experts in nanotechnology to improve the efficiency of seeding material. But of course, she has now created something that's got a huge affinity for water, being very hygroscopic. So then it also creates some practical issues for the storage, for the dispersion into the atmosphere. But I think you have overcome many of those. And so this is just an example that if you develop something new, you need to think about all the practical issues of going into the atmosphere and delivering these things inside clouds before it's only then that you can start finding out how efficient they actually change real clouds. The modeling, of course, helps us a lot. And one-dimensional models are simple in certain aspects, but also complicated in other aspects. So they don't represent the dynamics of the atmosphere and entrainment and all those sort of things very realistically, but you can deal with the microphysics in a much more detailed manner. So I would like to ask Professor Estefan Geresdi about the interplay between models of this sort, like the 1D parcel model, and maybe working hand in hand with cloud chamber studies, and so that your observational studies in detail and the model studies can be collaborated and support each other. So I would like to hear your comments on that. And then I've got another question to you regarding the size ranges. But if you could do this one first, I would be most happy.
Okay, so that's at first, that's the interplay between the different model scale. That's the, you are right. So that's the 1D has a lot of disadvantage. Of course, that's when we try to describe the for example, the cloud dynamic. We also neglect the fallout effect and so on. But that if we can focus on the microphysics, so we can see that some very, very detailed description about how, for example, that the water drops start to form even below the cloud base under saturated conditions. So that's, I think that's the first step is important, can happen in the atmosphere in the case of the hygroscopic seeding. That's what's happened under the cloud base. And after that, that's a competition between the different type of particles. So I think that's my results confirmed it. That's the competition is very important, and so that's the reason we choose the 1D. So from the 1D model, we can move to a different direction. So one of you mentioned, okay, so that's the comparison with the cloud chambers. So that's to simulate what's happening in the cloud chamber. So that's in this case, that's the situation is that the scale is so one point of view is smaller because that's the size of the chamber is smaller. And in this case, we can focus on the microphysics, but to simulate what's happened to microphysics, so that we need a very good spatial resolution. So what's happened in the chamber to take into consideration everything. So in this case, we have to move into the direction of the smaller case. I mean, that's if we want to see that the spatial resolution of this type of model can be as small as a few centimeters. So this is the one way of the improved simulation and have some comparison with the observations. I think it is important, and as I know that it's getting more and more involved, more and more scientists involved. There are a number of new laboratories, and so we have a great challenge about the simulation, what's happened in this laboratory, in this chamber. So that's it. That's this. If you understand what's happened there, so it can improve our knowledge significantly, I think. And I think that it is another way. Roloff mentioned the field observation to have a better understand and the comparison of the field observation. We need a large scale model. So we have to, I think that we have to move into other direction as well to see how a 3D model with larger scale, because in this case we can have a comparison with the field observation as well. So I think both direction is important. And I think that's because, I just, my history, my story, but it is not so important, but I have to mention, that I started my career almost 40 years ago. So that's, I remember that's the capacity of the computer comparing with the nowadays. So that's not only our knowledge increased significantly in the last half century, but our chance to have a more detailed simulation about that. Of course, I think that the same situation happens in the case of the observation as well. So I think that the other way is also important to develop a 3D model and with good spatial resolution to understand. So that's to make a comparison between the field observation and the model results. So that's I think that the scales of the model can cover our scale in the field scale of the different type of observation. And so that's I believe I have a dream, that the models and the analysis of the model data can help to understand the physics happens in the clouds, especially in the case of the hygroscopic seeding. So that's my dream. So that's I can tell you.
Thank you very much. That makes a lot of sense. I think those two directions, not stopping to focus on the microphysics in quite some detail, in combination with cloud chambers where possible. But on the other hand, we need to move into something on a scale that is more realistic in terms of storms and clouds and rainfall, because that is the ultimate goal. We want to see what we can achieve there. But I think as we go through this discussion, it's just clear how you need to use all the tools available to systematically move from the research environment into operations. And if you miss a step, it's very dangerous because it will come back and bite you and you will have to go back to the beginning and repeat the process. Something that I also think is quite important is that you must always make sure that the theory and the models and the observations go hand in hand and mutually support one another. So this is stepwise way of going about that. So before we go away from you, Prof. Istvan, can you just say that nanomaterial or not coated, if you have released normal sodium chloride particles of the same size, what would have been the difference in your modeling results?
Yeah, okay, I did it. So that's, as I mentioned, that's in the case of the nanoparticles, so that's the results for sensitivity, as I mentioned, of the X factor. I mean, that's how the hygroscopicity decreases as the size of the drops form on it. So that's the results for sensitive. And also when that's when I suppose that the X is relatively small, so that it means that the hygroscopicity is slowly decreased with the size. So in this case, that's the effect was significantly larger than the soap particles. But when the decrease with the decrease of the hygroscopicity was relatively significant when the size decreases. So in this case, the difference was not so large. Because that's when the hygroscopicity decreased very fast. So this means when the drops reached the cloud base, so this was almost the same as the salt particles.
Yep. So yeah, that's important that we just focus on that and remind ourselves. We have another 4 minutes or so before we need to move into the next session. So I want to return to Sofian and just ask him how the seeding program is going the past year and what highlights have been achieved. And is there anything in the operational work that you do on a day-to-day basis that you've learned new things that could help in future with this new seeding nanomaterial? Is there anything new in the past year in terms of operations that you think would be useful when you move over to start doing some serious testing on this material?
Yeah,
could be in the use of radar or anything.
Yeah, actually, nowadays we are using these nanomaterials in spite that we didn't yet receive or reveal the results from the open atmosphere using this in convective clouds in reality. But we rely on this actually at these times. And the cloud seeding operation it is very clear to everybody now. It's been more active comparing to the previous years. That actually because of we are owning different airplanes and pilots, and we have a division here specialized for the cloud seeding as a unit in cloud seeding operations. Hopefully that these results, also the tested results from the nanomaterial, will try to market these materials in the future, and will ask many countries that or committee of cloud seeding to use these materials in the future. But it is really obvious for the cloud seeding operations in the country has been improved, and And many people now, locals, they have a good experience in managing the cloud seeding operations.
That's really fantastic. You've done such a
And
marvelous job
yeah.
in the UAE.
And newly they
So-
made different studies on the target and the areas to see the difference in the outcomes of cloud seeding results.
Yeah, I think you have all the tools in the UAE now in terms of your very sophisticated radar network. You've got skilled staff, you've got excellent aircraft. And it's also very good to start practicing to use a new material, even in parallel when all the other experiments and research is still going on. So yes,
Exactly,
absolutely.
yeah. That's what we are doing now, yeah.
So because eventually all these things need to come together at once when it's mature enough, and we look forward and will continue to follow the development very closely. So I want to close this panel discussion now, and I want to thank the two participants and presenters, Mr. Sofian Farah and Professor Istvan Geresti, for the presentations. Very insightful. Exciting work. This is one of the initiatives out of the UAE program that really ventured into new fields, and of course Dr. Roelof Breintjes that also joined the panel due to his expertise in this field and his involvement in the move towards applying this material in real clouds. So thank you very much, and move on to the next session.
Thank you.